Hello friends, welcome to Prabin's Academy. Our next topic is electric field. Okay, before that we have to understand about source charge and test charge. Okay, source charge, or another name is active charge. Active charge. Source charge means the charge which is producing the electric field. The charge which is producing the electric field. Okay, next one, test charge. Test charge, or another name passive charge, or another name unit positive charge. Okay, this charge, the charge which is used to test the effect of source charge. Okay, the charge which is used to test the effect of source charge. Okay, once more, source charge means which is producing the electric field. Which is producing the electric field. Test charge means which is used to test the source charge. Which is used to test the source charge. Okay, that is, when we place a positive charge, here, its effect will be there for a small region. Okay, its effect will be there for a small region. If we bring another positive charge to the surrounding of this source charge, okay, if we bring another positive charge to the surrounding of the source charge, what will happen? It will repel. Okay, its repulsion will increase towards the source charge. Okay, its repulsion will increase when it moves towards the source charge. Okay, so this surrounding is called electric field. Okay, this surrounding is called electric field. Okay, next definition, electric field. The region surrounding a charge where its influence is felt. Okay, the region surrounding a charge where its influence is felt. Okay, this is the surrounding of this source charge. Okay, next definition, electric field intensity. Electric field intensity. Electric field intensity denoted by capital E. Okay, it is defined as electric force. Electric force, it is defined as electric force experienced by a unit positive charge placed at a point. Okay, it is defined as electric force experienced by a unit positive charge placed at a point. Simply we can write electric field equal to force by unit charge, okay, or test charge. Electric field E equal to force by unit positive charge or test charge, or Q0 equal to test charge. Okay, this is the equation for electric field intensity. Okay, unit of electric field intensity is Newton per coulomb. Okay, Newton per coulomb. Also dimensional formula equal to, for the force, ml t raised to minus 2, and for charge it is it. Okay, then ml t raised to minus 3, I raised to minus 1. Okay, also next point, electric field intensity is a vector quantity. It is a vector quantity. Next, electric field intensity at a point due to point charge. This is our second small derivation. Okay, consider a point charge Q. Okay, consider a point charge Q placed in air or vacuum. Let Q0 be the test charge. Q0 be the test charge placed at a point P. Okay, placed at a point, say P, at a distance R from Q. Okay, then we have to find the electric field intensity. Okay, that is, consider a point charge Q be placed in air or vacuum at a point, at any point, at a point. Okay, at a point. Let Q0 be the test charge at a point P at a distance R from Q. Consider a point charge Q be placed in air or vacuum at any point. Let Q0 be the test charge at a point P at a distance R from Q. Then force experienced by Q0. Force experienced by Q0. Okay, that is Coulomb's force. Coulomb's force experienced by Q0 is F equal to 1 by 4 pi epsilon 0 Q0 by R square. Take this as equation number 1. Coulomb's force is 1 by 4 pi epsilon 0 Q0 by R square. Okay, then electric field intensity at point P is equal to F by Q0 by our definition. Okay, equal to F by Q0. Take this as equation number 2. Then substitute equation 1 in equation 2. What will be the result? E equal to 1 by 4 pi epsilon 0 Q by R square. Okay, Q0 will cancels. Then we get E equal to 1 by 4 pi epsilon 0 Q by R square. This is the equation for electric field intensity at a point due to a point charge. Okay, Coulomb's law is 1 by 4 pi epsilon 0 Q1 Q2 by R square, but electric field intensity at a point is 1 by 4 pi epsilon 0 Q by R square. Okay, only 1 Q. Or in a vector form, we can write this equation as E equal to 1 by 4 pi epsilon 0 q by r square into r cap. Okay, q by r square into r cap. Also the shape of graph relating E and R is like this. E R, the shape will be like this because E inversely proportional to 1 by r square. Next is superposition principle. Superposition principle of electric field intensity. Okay, for that consider a system having point charge q0 and test charges q1, q2, q3, etc. qn. Okay, at a distance r1, r2, r3, etc. rn. Okay, then by superposition principle, it is the vector sum of individual electric field intensity, that is E equal to E1 plus E2 plus etc. En. Okay, that is, consider a system having charges q1, q2, etc. qn at a distance r1, r2, etc. rn from a point charge q0. Then by superposition principle, E equal to 1 by 4 pi epsilon 0 q1 q0 by r1 square plus 1 by 4 pi epsilon 0 q2 q0 by r2 square plus etc. 1 by 4 pi epsilon 0 qn q0 by rn square, or E equal to E1 plus E2 plus etc. En. Okay.